assuming we arrive at a space-time tunnel. Riding the reverse arrow of time within the tunnel, we travel back 20 years ago, shortly after the new millennium. Our nation had just joined the World Trade Organization. The economy began to prosper. Cities gradually developed, with several office buildings towering in urban areas, while the croak-filled streamsides occasionally echoed with the rumble of trucks. We will not linger here long, for our journey through time has only just begun. Continuing to shuttle through the space-time tunnel, we arrive at a scene of chaos. Warlord factions engage in relentless warfare. Dilapidated roadsides are crowded with displaced refugees and fleeing masses. Distant gunfire and cannon roars intermittently pierce the air. Though the corrupt Qing dynasty had collapsed over a decade prior, people's lives failed to improve. Instead, the social environment deteriorated further, as warlords, foreigners, landlords, and local tyrants desperately sought to suck the last drops of blood from already drained peasants. The space-time tunnel's footsteps do not halt. We arrive 600 years ago. The magnificent Forbidden City has just been completed. Under Emperor Yongl's patronage, Zheng He embarks on another maritime expedition. Domestic production revives. People's livelihoods gradually stabilize. Everything manifests the final glorious chapter of China's feudal society. Pressing forward, the space-time tunnel reactivates. 1,300 years ago, the scene before us appears fantastical. On the streets, you see not only dark-haired, dark-eyed Central Plains inhabitants, but also numerous high-nosed, blue-eyed Westerners. The bustling thoroughfare teems with pedestrians and vehicles. None but you finds this astonishing. The Western market overflows with exotic goods. Grapes, Persian herbs, Huan pine nuts, everything imaginable. The clinking of Kaiyuan coins creates an incessant metallic chorus. Indeed, you've arrived at the Tang Dynasty, the zenith of Chinese feudal society. The space-time tunnel's journey does not stop here. We now arrive at a scene where Han and Hu armies are engaged in fierce battles. Moving further back to 2,100 years ago, a Han emperor is presenting a ceremonial tally to a man. The recipient takes the tally, slowly turns his head, and marches westward. Later generations will know that it was because of this man that the Silk Road came into existence, making the Hushi Corridor and western regions inseparable parts of China's territory since ancient times. The Grand Curtain of the Western Han Dynasty's prosperity is gradually rising. The space-time tunnel continues its journey to 3,300 years ago. Diviners are carving pictographic symbols on turtle shells, what we now know as Oracle Bone script. As the shells crack in the fire, the priests gather to examine the results. This divination appears highly auspicious, and the group begins singing and dancing around the fire in celebration. Pressing forward through time, we reach 5,000 years ago on the Chinese land, a walled city with an intricate waterway system, where timber, jade, and other raw materials are continuously transported via canals. The wood goes to the central high ground for palace construction, while the stones are sent to workshops to be crafted into exquisite jade song artifacts with square exteriors and round interiors. This still isn't our final destination. As time rewinds further, we come to a small hillside covered with grasslands and low vegetation, dotted with scattered trees. This is Yunnan region 1.7 million years ago, where several hominins with features intermediate between apes and humans are foraging for food. This is our starting point. The group we see are the Homo erectus yuanmuensis. On May 1st, 1965, while conducting geological surveys to support the construction of the Chengdu-Kunming Railway, geologist Qian Fong and his team discovered two ancient hominin teeth fossils in the Yuanmo Basin of Yunnan Province, at a location northwest of Shangnabang village. After examination, these teeth were confirmed to belong to Homo erectus, literally meaning upright walking ape man. These represent the earliest known human ancestors within China's borders, now referred to as the Homo erectus yuanmuensis. In 1984, a field team discovered a left tibia fossil approximately 250 meters from the original Homo erectus yuanmuensis site. According to the latest dating results, This tibia dates back at least 1.4 million years, with possible dates ranging between 1.7 to 1.4 million years ago. Although found in a geologically younger stratum, it should still be classified as Uenmo Homo erectus. Between these two discoveries, during the 1973 archaeological excavations at the site, stone tools contemporaneous with the Homo erectus uenmoensis era were discovered, which are believed to have been used by them. To facilitate understanding of hominin evolutionary stages, let me briefly outline the general human evolutionary process. Modern humans and apes, including gorillas and chimpanzees, all evolved from ancient apes, with our last common ancestor living more than 7 million years ago. Between 7 to 5 million years ago, humans and modern apes began diverging along separate evolutionary paths. Early human ancestors, here collectively referred to as ape men, include Sahelanthropus cadensis, Ororin tugenensis, and Ardipithecus ramidus. Between 4 to 3 million years ago, evolution reached the famous Australopithecus stage. Multiple Australopithecus species discovered in Africa have been confirmed to walk upright, the key distinguishing feature between humans and other modern apes. Later came Homo habilis and Homo ergaster, whose names indicate their tool-making capabilities, with the latter producing more diverse tools. Then emerged Homo erectus, to which the Homo erectus uenmoensis belongs. Homo erectus migrated out of Africa around 1 million years ago, spreading to Asia and Europe. By about 200,000 years ago, early Homo sapiens appeared. Around 100,000 years ago, some evolved into anatomically modern humans, Homo sapiens sapiens, who again migrated from Africa worldwide. Mainstream science considers all modern humans as descendants of these late Homo sapiens. The term sapiens, meaning wise, might reflect human self-flattery. Approximately 1.1 to 0.7 million years ago, a group of Homo erectus lived in what is now Lantian County, Shaanxi. Like the Homo erectus uenmoensis, they belonged to Homo erectus. In May 1964, researchers from the Chinese Academy of Sciences discovered a nearly complete middle-aged female skull fossil at Gongwangling in Lantian County, dating back about 1 million years. The Homo erectus lanchinensis had thick brow ridges, very low and flat foreheads, and extremely thick skull bones, their appearance more closely resembling ancient apes, classified as early Homo erectus. The stone tools found in their activity areas were crudely made, created by striking one stone against another to produce approximate shapes with desired functions, then further refined. The stone tools discovered in the Homo erectus lanchinensis's territory include choppers, scrapers, large pointed tools, and stone balls, used for hunting or food processing. Several small, concentrated ash deposits were also found, possibly indicating the Homo erectus lanchinensis's use of fire. Between 700,000 to 200,000 years ago, another Homo erectus group lived in what is now Zhoukoudian, Beijing, known as Homo erectus pekinensis, also called Peking man or Beijing man. Their fossils were discovered in the 1920s, with the first complete skull found by Pei Wenzhong in December 1929. Over subsequent decades, archaeologists discovered 5 more Peking man skull fossils. These skull fossils helped reconstruct their appearance. Their faces were slightly shorter and more protruding than modern humans, with low foreheads and high cheekbones. Imagine small foreheads with prominent cheek areas. They had thick brow ridges that protruded significantly, retaining many ape-like characteristics, though overall showing fewer primitive features than the Homo erectus lanchinensis. Peking man continued making flake stone tools while also incorporating animal bones to improve tool functionality. They used stone tools for hunting and gathered plants for food. It's now generally confirmed that Peking man could use natural fire and possibly maintain fire, using it to cook food, provide light, or ward off wild animals, a crucial step in human evolution, as early humans were still ordinary members of the natural world, lacking advantages in strength or speed compared to large predators. Individual survival was difficult. Thus, Peking man lived in groups, typically forming small communities of a dozen or several dozen individuals, who worked collectively and shared resources equally. This represents the egalitarianism of primitive society. Around 30,000 years ago, another group of people lived at Zhoukoudian, where Peking man once dwelled. They belonged to late Homo sapiens, our direct ancestors, known as the Upper Cave Man. The fact that Peking man and Upper Cave Man inhabited the same area isn't coincidental. During early human development, with limited ability to transform nature, they often sought naturally secure habitats like caves near reliable food sources. These locations, remaining relatively unchanged, could become home to different groups when resources were abundant. This explains why both Peking man and Upper Cave Man occupied the same site. It's somewhat analogous to how auspicious burial sites in ancient times often contain graves from multiple dynasties. From 1933 to 1934, excavations of the Upper Cave deposits uncovered 3 complete skulls along with skull fragments, mandibles, individual teeth, and postcranial bones. Analysis of Upper Cave Man fossils shows their morphology was essentially identical to modern humans in facial features, height, and other characteristics. Additionally, numerous decorative items were discovered, including perforated stone beads, pierced pebbles, drilled animal teeth, and engraved bone tubes, indicating Upper Cave Man had developed aesthetic sensibilities. They buried their dead, sometimes sprinkling red ochre powder, suggesting primitive religious beliefs. These advancements all pointed toward the development of clan societies and the emergence of class distinctions. Beyond these well-known hominins, numerous other fossils and stone tools from various periods have been discovered across China, such as the 300,000-year-old Homo erectus hexionensis from Anhui, the 150,000 to 200,000-year-old Homo sapiens daliensis from Shaanxi, and the approximately 100,000-year-old Homo erectus dinkinensis from Shaanxi. Although hominin fossils from different periods continue to be discovered, paleoanthropology still faces significant challenges. The primary challenge is dating hominin fossils, the foundation of paleoanthropological research. However, determining fossil ages remains contentious. Current dating methods for hominin fossils or sites include uranium series dating, radiocarbon dating, electron spin resonance, thermoluminescence, paleomagnetism, cosmogenic nuclide dating, ESR/U series combined dating, amino acid racemization, apatite fission tract dating, and potassium argon/argon-argon dating. Because fossils are discovered at different times and locations under varying social conditions and technological capabilities, dating results are sometimes questioned. For example, the Homo erectus yuanmuensis teeth were dated using paleomagnetic sampling, suggesting they lived 1.7 million years ago. Later, some scholars argued the Yuanmo Basin's complex stratigraphy and strong neotectonic movements had disturbed the fossil layers, combining geomagnetic characteristics. They proposed the Homo erectus yuanmuensis lived 700,000 to 600,000 years ago. Subsequent studies using amino acid racemization, electron spin resonance, and more precise paleomagnetic techniques on the teeth or surrounding animal fossils generally support the original 1 to 1.5 million year estimate. Thus, dating hominin fossils remains complex, and current results may not be final as methods continue evolving. Moreover, China's human fossil dating platforms have long lagged behind developed countries, often relying on commercial testing services where poor communication with technicians can lead to dating inconsistencies. During excavations, inaccurate stratigraphic assessments due to geological changes, improper dating methods, or operational errors can produce skewed results. Informal excavations that fail to record fossil locations or stratigraphic data leave some sites undated or lacking credible data. These dating issues constrain research on human evolution while simultaneously presenting significant opportunities for advancement in this field. Interested researchers could explore innovations in dating techniques or theoretical work in related geological and paleontological disciplines. While these fields might be considered career discouraging in today's society, pursuing one's passions can lead to groundbreaking achievements after all. Love for the subject can make enduring long years of research worthwhile. Another challenge involves confirming hominin tool use and fire control. Generally, stone tools found in the same stratum as hominin fossils can be attributed to them after careful analysis. However, because fossils and tools aren't always co-located, and various environmental and geological factors may separate them, some sites preserve only fossils while others preserve only tools, even when both are present, after hundreds of thousands of years of geological processes or due to incomplete excavation records. Matching tools to specific hominins remains problematic. The most extreme case is China's earliest recognized hominin fossil, the Hetao man, discovered in 1922 along the Salawusu River in Inner Mongolia's Ordos region. The initial find was a single human tooth, followed by some skeletal remains and stone artifacts. For decades, Hetao man was considered an important late Pleistocene fossil human in northern China. However, because these remains weren't excavated systematically, their stratigraphic context and age were unclear. Recently, dating of a femur collected in 1923 by separate U.S. and Chinese labs yielded consistent results of 200 to 300 years old, indicating modern human origins rather than fossil humans. Another limb bone found on the site's surface dated to 2,751 years ago, showing the site's human remains can't be simply attributed to any single period, casting doubt on whether Hetao man qualifies as a fossil human. Identifying fire use is even more challenging. While burned materials may survive, the act of fire use doesn't fossilize, making it difficult to distinguish between human-controlled fire and natural wildfires caused by lightning. Consider Peking man's purported fire use. Since 1929, charred or blackened animal bones have been found in Zhoukoudian's deposits, confirmed through testing to have been burned. Anthropologist Davidson Black analyzed these as evidence of Peking man's fire use. However, starting in 1985, American scholar Louis Binford, pioneer of new archaeology, challenged this view from a taphonomic perspective, arguing the evidence was inconclusive. Subsequent localized sampling at Zhoukoudian failed to find definitive proof of in situ fire use, further questioning whether Peking man could control fire. Later, extensive sampling by the Institute of Vertebrate Paleontology and Paleoanthropology, IVPP, and other international teams showed sediments in the purported fire areas reached temperatures exceeding 700 degrees Celsius, beyond typical natural fires, possibly indicating human-controlled fire. However, whether these were actual hearths or redeposited materials requires further study. Academic debate is healthy, reflecting scholarly rigor. Of course, debates should exclude political influences, though difficult, as only purely academic disputes can advance a field. Perhaps the most contentious issue is human origins. From the 1890s Java man discoveries in present-day Indonesia to the 1920s Peking man finds, pushing human evolution back hundreds of thousands of years before older African hominins were found. Most anthropologists believed humans originated in Asia, as earlier African fossils of Homo erectus, Homo habilis, and Australopithecus emerged. Consensus shifted toward African origins. Research shows Homo erectus migrated from Africa over 1 million years ago, followed by early Homo sapiens around 200,000 years ago, and late Homo sapiens roughly 100,000 years ago, all spreading from the Middle East's Fertile Crescent into Europe, Central Asia, and East Asia. But regarding modern human origins, scholars diverged. The multi-regional evolution model posits that after Homo erectus left Africa, populations across Eurasia evolved independently through geographic isolation, natural selection, genetic mutations, and gene flow, converging toward modern humans through parallel evolution. However, in 1987, molecular biologists entered the fray with the recent African origin theory, arguing based on mitochondrial DNA that all modern humans share a common African ancestor no older than 200,000 years. According to this view, modern humans descended from African Homo sapiens who migrated via the Sinai Peninsula into the Middle East, then Europe, East/Southeast Asia, and finally Oceania and the Americas. The two theories remain hotly contested. Multi-regionalists base arguments on fossil anatomical continuity and stone tool cultural connections, while single-origin proponents cite chromosomal and genetic evidence. Notably, East Asia shows a puzzling lack of human sites between 100,000 to 40,000 years ago, a gap period single-origin advocates attribute to harsh climate causing local extinction, with later African migrants replacing indigenous populations. However, recent research reveals late Homo sapiens interbred with earlier humans like Neanderthals and Denisovans, meaning modern humans may retain some archaic genes. As data accumulates and methods improve, the origins debate should clarify.